chat about the graphs. Graphs are one of the important concepts of data structures and algorithms. So I just want you to please focus from now. So first of all, what are graphs? Graph is defined as a set of vertices and edges in which any two vertices can be connected through an edge. For example, if we take some vertices are also called as nodes, then here the edge can be between any two vertices. Like in if we take a tree, then there could be a possibility of the edge between the vertex 1 or let's say A, and this is as B, and this as C, and this is D, and this is E. Then for a tree, we can only define the edges in this manner. Like for a tree, we can't define an edge between a child and its parent node to form a cycle. Cycle can't be possible in a tree. But whereas in graphs, the edge between anything like here, the any two node can connect with any other node. Like so here comes a point. Like for a graph with n vertices, how many possible maximum possible edges can be possible? For example, if we take, let's say a graph has a graph of n vertices can have the maximum of n into it's nothing but selecting all possible selections from the n items, all possible selection of two items from n items. It means nc2, which is nothing but n into n plus 1 by 2. So therefore, the maximum number of edges that can be possible in a graph with n vertices is n into n plus 1 by 2. And I hope this is clear. Next, and graphs are mainly divided into two categories. Like first one is directed graph, directed graph, and the other one is undirected graph. Each edge here in the undirected graph, each edge represents in the case of undirected graph, each edge represents that there is a relation between A to B and as well as B to A. Each edge A to B represents that and whereas in the case of directed graph, the edge is represented with an arrow mark. Like if in the case of directed graph, if we say that there is an edge between A to B, from A to B, then it only implies that we can go from the node A to node B. We can't come back from B to A. And this is represented by an arrow mark, whereas the undirected edge is represented by straight line. So let's discuss some of the important terminologies of the graph. The first one is degree. Degree for undirected graph, the degree is defined as the number of edges that are coming through a particular node. Degree of the node is defined as the number of nodes coming through it. In the case of directed graph, degree is classified into two types. One is in degree the number of nodes that are coming through the node, and the other one is out degree, is defined as the number of edges coming through the node. And the other important terminologies are acyclic, cyclic, these are very simple, and weighted graph. Unweighted graph, planar graph, complete graph, full graph. Let us write this. Let's see the definitions of each term line by line. First is a cyclic graph, a graph which does not consist of any cycle is called as a cyclic graph. For example, if we take this graph and let us delete some edges. Now, if we consider this graph, we can clearly see that there is a formation of cycle. Like if we start from the node 1 and traverse in this way, we can again reach to the node 2, which represents that there is a cycle in this graph. If the graph consists of at least one cycle, then it is called as a cyclic graph. And in the case of a cyclic, the graph should not contain any type of cycle. At least one cycle also should not be present in the given graph. For example, if we take the above graph and paste here and remove any of these four edges, then it will become a cyclic graph. Here we can see there is no cycle between the graph, like between any edges. The next one is weighted graph. Here, if the also represents any weight, like the distance in the case of city and distance graph, like that, then the weight is represented at the above of this edge. Like here, if the weight of this edge is 2, then we represents 2 here, and the weight of the edge is 3, then we just simply represent 3 at the near of this edge. And similarly, we represent the edge weight of this near at this edge, and we also represent, like, we can also represent the edge weight of this. Unweighted, the graph which does not consist of any weights, like, or else the weight of all edges is same, like every edge represents 1 unit of distance or 2 unit of distance, then we don't need to maintain the weight for every edge. In that cases, we use the unweighted representation of the graph. The next one is planar graph. Planar graph, the graph which can be drawn easily in a 2D plane. For example, if we take this graph, here we were easily able to draw this in a 2D plane. But if we take this graph like non-planar, non-planar graph will actually look like this. There will be no crossed edges, and it can be easily represented in a plane, 2D plane. Let's say if there is an edge between there is an extra edges between E to B and A to C. Here we got an intersection point, which represents that we can't represent this in a 2D. No, sorry. We can actually represent that this is not a planar graph. This is a non-planar graph. This is also a planar, because you have to try your best to represent that. And if you are not able to represent that in a 2D, then it is known as a non-planar graph. Here we can simply represent this in a 2D plane, like Here in this manner we can represent. But if I take you to the other graph like non-planar, let me give an example for non-planar. Non-planar, then the graph like this, we can't. Let me take this and read. And here, if I have the graph like this, and there is an edge between D and A, like D to B, and so if we have an edge between D to B, and as well as from the like, yes. So if the graph is like somewhat, and there is an edge between, actually you can draw a non-planar graph without like with four edges. The simplest non-planar graph can be drawn with five vertices only. Let me erase this and draw a graph of five edges. Like it's very simple. It's actually the complete, I mean, full graph of five vertices. I'll tell you what is a full graph is just in a minute. Let me finish this. So this is what a simple graph. Even if we try to draw this without this overlapping, then we can't able to draw. Let's see. Let's try and see. Let's remove this edge and connect these two from here outside. And also remove this edge and connect this from this side. And now, if you want to join this edge, we have to cross this edge. It is not possible to connect these two edges without crossing any edge. So this is called as a non-planar graph. Let us discuss what is full graph. A graph, sorry, there is no term as full graph, complete graph. Sorry. This is also a complete. So this is all about the important terminologies of graphs. I hope you understand. In the next video, we're going to learn the representation techniques of the graphs. And I hope you like this video. If you like this video, hit the like button and share to your friends. Thank you for watching.